Hi all, I am here with my new video on reduction, oxidation and electrochemistry. Let's start. In this video we will learn about oxidation, reduction and redox reactions. Oxidation definition. The combination of a substance with oxygen is called the oxidizing agent. The substance is oxidized. Example, two molecules of magnesium react with oxygen and forms two molecules of MgO or magnesium oxide. Formal definition of oxidation: a loss of electrons. Let us examine the oxidation of magnesium by oxygen, this time including the oxidation number for each atom in the equation. We can see that magnesium has increased its oxidation number from 0 to +2. We know that charges arises from the loss or gain of electrons, so we can conclude that magnesium atom lost 2 electrons when it became oxidized. So we can write this oxidation as half reaction. Reduction definition. The removal of oxygen from a substance is called reduction. Example, copper oxide reacts with hydrogen and forms copper and H2O. Here hydrogen is called reducing agent. Copper second oxide is the substance that is reduced. Formal definition of reduction. A gain of electrons. Let us examine the reduction of copper second oxide by hydrogen and also include the oxidation numbers for each element in the equation. We note that the reduction of copper second oxide does not involve the oxygen because the oxidation number of oxygen does not change. However, the oxidation number of copper has changed from +2 to 0. We conclude that the copper gained 2 electrons when it was reduced. We can write this reduction as a half reaction, and it is as follows. Redox reaction. From the formal definition of oxidation and reduction, it is clear that the presence of oxygen is not required. Not only are oxidation and reduction opposite processes, but also one cannot occur without the other. If one atom loses electrons, there must be another atom that will gain them. We call all reactions involving oxidation and reduction redox reactions. In a redox reaction, the oxidizing agent is reduced and the reducing agent is oxidized. Example of redox reaction. Here we can see ammonia is react with oxygen and makes NO plus H2O. To find out this reaction is redox or not, we rewrite the equation and include the oxidation number for each element. Then we look for changes that occurred in the oxidation numbers as a result of the reaction. An increase means oxidation and a decrease means reduction. In this reaction, nitrogen changes its oxidation number from -3 to +2. Its oxidation number is increases and therefore nitrogen has been oxidized. Oxygen changes its oxidation number from 0 to -2. Its oxidation number decreases and therefore oxygen has been reduced. Hydrogen, whose oxidation number is not changed, is neither oxidized nor reduced. This is indeed a redox reaction. Spontaneous redox reaction. One example of a spontaneous reaction is where Zn reacts with copper ion and forms zinc ion and copper. This reaction is spontaneous in laboratory experiment in which a strip of silver grey zinc metal is placed in a beaker containing a blue solution of aqueous Cu2 plus ions, and a strip of red copper metal is inserted into a second beaker containing a colorless solution of zinc Zn plus 2 aqueous ions. In the first beaker, we will observe that the solution loses its blue color and the zinc strips become coated with copper metal. We observe no reaction in the second beaker. The loss of blue color and the appearance of metallic deposit indicates that copper ion is being converted to Cu copper metal by reduction. Like all redox reaction, this reaction involves a competition for electrons. Zinc loses electrons more readily than copper, and Cu2 plus ions gains electrons more easily than Zn2 plus ions. Reaction that occurs is Cu2 plus 2 electron and forms Cus, which is copper metal. The 2 electrons are supplied by zinc solid, which is oxidized to zinc 2 plus ion. The half reaction that occurs is zinc solid is converted into zinc 2 plus aqueous solution plus 2 electrons. The net equation for this reaction is zinc solid plus Cu2 plus aqueous and forms zinc 2 plus in aqueous solution plus Cu solid. This reaction is spontaneous in laboratory conditions, so the reverse reaction between copper solid and zinc 2 plus aqueous cannot be spontaneous. This is why we see no reaction in the second beaker. For next video, we will learn about electrochemical cells. To watch new videos, please subscribe and like.